So MBL brings together scientists and participants around the world for their summer courses. Supported by Leica Microsystems, these courses offer access to world-class imaging solutions for their research. Let's hear directly from the course director about their perspective on these courses and their tips for anyone planning to apply.
So it was very different from a course. Instead of having students come and having course directors who teach content and teach them new techniques, the Grass Foundation sponsors the lab, and they accept applications from early career neuroscientists from around the world. They could be late in their PhDs, in their postdocs, or even early in a faculty position. And they apply to come here and do their own independent research project for a whole 14-week-long summer. So the fellows come in and they're all working on different things, and I'm not an expert in their work and Oscar's not an expert in their work. They have to be the experts in their work, and we're here to support them, mentor them, give them all the tools they need to succeed.
So I have been in involved in the course since 1999, on and off. The very first day of my postdoctoral job in 1999 with Joan Hunt, who was one of the three founding directors of Frontiers in Reproduction. And the very first day of my job there, she asked me if I would like to go to Cape Cod to participate as a section TA, just like Sue, in Frontiers in Reproduction. Didn't have any idea what it was, but I just uncategorically said yes. No questions asked. And I've since then started to give lectures and eventually took on a laboratory of my own, and now as section director.
Well, the field of endocrine disrupting chemical research is fairly young, and it encompasses many different disciplines. There are chemists and biologists, and immunologists, and epidemiologists, and people who don't typically talk to each other or even meet at meetings. And those of us who were pioneers in the field found that we all started to gravitate to each other and talk across disciplines and help each other. We realized that to help the next generation get started in this field, we needed to help them learn about the different disciplines and to build bridges across the disciplines. That's going to be stuff.
So many students who are working in experimental systems at their home institutions have access to a certain range of imaging facilities, some more than others. We're very fortunate at Harvard Medical School, but at other places, they have not experienced the kind of imaging systems that the MBL is world famous for. And so Leica plays an enormous role. We've done experiments during the course that they would not be able to see the results on standard DNA systems, but the TWIS takes them through, and you can hear them go, wow, wow. And once you get in your head that you can see new things by these new types of microscopy, then you go back to your institution, maybe you put in a program project grant, maybe you get a donor to come and help you set up a new imaging facility. It literally opens their eyes to new possibilities that they had never even thought that they might be able to have access to.
I was a student in this course, and microscopy is the thing about it. It's really, as Joan said, it really is making science accessible, seeing what your own hands can do. And a big barrier to that is the intimidation by, how do I use this equipment? How do I use equipment safely? And so what we do is with this course, we bring in experts who know how to use the machines and take something that's so mysterious and make it accessible.
I took the class as a postdoc, and I actually did my PhD in the neuroscience of addiction. So reproduction is something that was actually totally new to me. So this class was a really incredible, deep dive into everything reproduction. And I feel like I couldn't have asked for kind of a better introduction to the field and the techniques in the field. And I learned so many skills that I was able to then go back to lab and start to do things in different tissues that I had almost no idea they worked before I came here. So yeah, that was the big thing for me, was just the breadth of knowledge and the techniques too. But I think FUR really taught me that the techniques that you read about are feasible. Like, they're not just this amazing science that you can only like see in papers. That, you know, if you have the right techniques and the right tools and the right people to teach you, that you can kind of do anything, which is really cool.
There are two things that come right to my mind. So the first one, last year we had a very smart grass fellow. His name is Guy, and he was the first person to ever do a CRISPR knockout in the horseshoe crab. And so it's the first time in the world, and it opens the possibility to do these genetic modifications in one of these organisms that is very interesting from an evolutionary point of view, but it also has a huge potential for biomedical research. And the other one was a collaboration that occurred organically in the grass lab of a few fellows a couple of years ago, in which they were working with ctenophores, and then they accidentally found that two of the ctenophores were fused, and so they started thinking of how to replicate this. And so they came with this whole brand new project that it was not even considered before the grass started. It was just born in the lab. And then they did a whole series of experiments that showed that ctenophores can fuse together. And so this is completely bizarre, because most organisms have a way to detect which part is yourself and which part is other, but ctenophores apparently lack those systems. And so it was completely bizarre. It got a lot of attention from the scientific reporting media.
So I'm myself work on zebrafish, so zebrafish are spectacularly transparent, so we can really do fantastic imaging. But what I really enjoy seeing here at the course is the marine invertebrates and also the arthropods. For example, when you look at oocytes or egg chambers in arthropods, the students usually stay in methaloidin with some other actin markers, and they're spectacularly beautiful. Honestly, we had, so in 2017 when I took the course, we had a laser, what is it called, what's the acronym? The LMD? There's a laser scope over, LCN is a scope over another building. They sat over and did a laser, like a laser dissection.
Yes.
But then the faculty retired. And then we didn't replace the faculty. And so we learned the technique, and obviously techniques that we learn evolve with time as well. Maybe not a lot of people utilize that instrument anymore because there's maybe better way of obtaining smaller particles from tissues. But yeah, I mean, that is something that students are interested in learning. We could reintroduce those technologies back into the course.
Nice, very much sure. And I think that is something that we're talking about, bringing that to the course as well. We have, definitely considered reintroducing that. As the technology evolves, we recognize that one piece of technology is very new at the time, so we bring that in, and then more and more people become familiar with that, and it becomes not something so new anymore. But then there's another big advance in that technology, so we reintroduce things.
So starting in the fall, the advertisements go out. So we advertise the course, through social media, through some of the journals and so on. So the students will apply, and the applications are due around January. We usually extend them almost every year. So they have to submit letters of recommendation. I think it's a fairly simple application. And MBL, because we are funded by some grants, so provides very good support for students who are coming to the course. So it sounds like it's a lot of money, but in fact, we subsidize the cost for most of the students who are coming to.
Sometimes people underestimate their own abilities. So I think really just everyone has a shot when they apply. So I like to really strongly encourage people to apply. I come from an undergraduate institution. And so, my students sometimes think, oh, we don't have the same experiences as someone from a big R1 or a big name institution. And that's just not true. And so I think really just opening the doors and trying to say, yes, everyone should apply. It doesn't matter what your pedigree is or what your past experience is. We want to open the doors. We want to increase participation in neuroscience across the field. We want to give lots of people these opportunities from all kinds of different backgrounds.